So we've got a straight line intercepting a curve, and apparently it goes through this curve in two different places. Now this is a simultaneous equation, because what I'm going to do is I'm going to take this definition that y equals 9 minus x, and I'm going to take out of the curve C, everywhere where there's written a y, I'm going to replace it with what y is equal to. In other words, y squared minus 3x, not y, but what y is equivalent to, 9 minus x, and plus 2, not y squared, but 9 minus x squared equals 0. Because if these two lines are going to meet, they're going to have the same coordinates in the same place at the same time. This is why we call them simultaneous equations. So x squared, let's simplify what we've got. 3x, otherwise minus 27x, and minus 3x plus by minus x is plus 3x squared. And I'm going to factorise up this bracket first before I multiply through by 2. So we've got that, haven't we? And now one more simplification, and then I'll tidy it up. So 2 times by 81 is going to be, what, 162. 2 times by 80 is minus 36x, and 2 times by x squared is 2x squared. Okay, this is looking to start much more healthy. Let's add the x squareds up. We've got an x squared here, an x squared there, an x squared there. So I've got 1 plus 3 plus 2 is 6, 6x squareds. I've got a minus 27x, and I've got a minus 36x. Add those two together, and you get minus, what, 63? Minus 63x. And the last term is the plus 162. There's no other numbers, so that's it. It's already simplified. So plus 162, and I've got to solve this. Now, I'm just going to see if the new version of calculators have the quadratic equation solver in them, because I haven't used this time to calculator before, but it's probably the type that you have at the moment. So I'm just dividing through by 3 to simplify it. I'm dividing everything by 3. Should make the question a bit simpler. Then I'm going to see if my new calculator's got a quadratic equation solver. Now I could use the formula, I suppose. So just scroll through the menu there, and different look like there is. So no, I don't. I'm going to have to do this the old-fashioned way. I'm going to have to factorise this. Okay, so factorising. So if you do, we're looking for two numbers that when you multiply them make 2 times by 54. This is called the AC method, isn't it? And when you add them together, make minus 21. Now, if you've been taught by me, you would have practiced this in year 8 and year 9. But if you don't know how to do this, then do come and find me, and I'm very happy to show you this. It takes about 10 minutes to learn, but it's really worthwhile. So where did I get the 108 from? Well, it's 2 times by 54. The outside numbers multiply together with the inside number below, minus 21. What I'm doing is I'm looking for two numbers that when I multiply them make 108, but when you add them can make minus 21. So I'm writing down the factors. 2 times 54 is 108, 3 times by, what, 36, is that right? I think so. 4 times by 27, still not a gap of 21, so I'm looking for that 21. So I have to keep going. 5 won't go in, 6 will go in, won't it? So that will be 6 times by, what's that going to be? 6 times by 18. Yeah. 7 won't go in. What about 8? Will 8 go in? No, it won't, but 9 will. So I think that's what I was looking for, 9. And 9 what? So 9 goes into 108 12 times. And I think that's it, because I can make 21 with a 9 and a 12, and I can make 108 with a 9 and a 12. So I think they're the magic numbers that I'm after. Okay, 9 and 12. Yeah, I'm just for the sake of cleaning, 7 won't work with it, but 8 won't work, but 9 and 12 will. So how do I use these numbers that I've discovered, 9 and 12, to help me factorise this equation? Well, what you can do is you can draw the flag of St. George, a flag, and you can write in the question, and you can take the highest common factors, and that will be the answer to this problem. I seem to have gone off camera, I don't know why that's happened, sorry about that. I'm going to move it up in a second. In any case, here we go. So that is now factorised. You can check, if you model this back out, do you get up to 2x squared minus 21x plus 54? You can see therefore you're going to get an answer for 1 is going to be x1 equals 6, and the other answer will be when 2x minus 9 equals 0, which will be at 4.5. How do I find the y coordinates? Well, if you look at the top of the page, you've got an equation for y. Y is equal to 9 minus x. So 9 minus 6 is equal to 3, and 9 minus 4.5 equals 4.5. So they're my coordinates. To the left of the 3 now, you can see what I did with my magic numbers 9 and 12. I wrote down the question to be factorised, 2x squared minus 9x minus 12x plus 54, because you can see minus 9 minus 12 equals minus 21. Okay, so let's have a look at the pause mark scheme, have a read. And let's hope the answers are 6, 3 and 4.5, 4.5. And they are. Okay, so do come and find me if you don't know how to factorise quadratics. It really is quite quick.